All right, this is the lesson launch for 221, special angles in the unit circle. And we started this lesson in chapter 1 at the end with 131 and 132, and these are the ones we went over the last class when we met. 131 is when we learned what the radian is. It's just a radius angle, and it's a unit of measure for angles. And we can convert from radians to degrees and degrees to radians. And 132, we took the circle, cut it out, folded it up, and found the common angles. And the common angles are the special angles in the unit circle. And the special angles are the special right triangles, the same angles in the 30, 60, 90 and the 45, 45, 90. And we'll use that extensively in further chapters and lessons in pre-calculus. So we know how to convert between radians and degrees. And let me move myself out of the way here. So as I scroll down here, you'll see this little circle here on the right is the common angles or the special angles. And if you superimpose a 30, 60, 90, we know what those ratios are, and we know which each of these sides are and the ratios of those sides. And with the unit circle, the hypotenuse is going to be 1. So all we need to do is figure out the other two sides. And what they're asking is, what is the x component going to be and what's the y component going to be? So since we know what the size, the x component is how much we travel over on this x degree, so it's just going to be what the length of this side is going to be, and the y component or vertical component is just going to be what the length of this side is going to be. Whether we use trigonometry or Pythagorean theorem, you'll still get the same answer. So let's work through a couple of these problems, and you can do that with either the resource page that they provide for you, cut it out, and cut these circles out. And once you find the ratios of each of these circles, you can find each of these horizontal and vertical components and find the x and y coordinates for each of these points of the special angles. I'll also provide this link for Desmos and show you here what each of these are. So this is the one that was pictured there, and this is where it overlaps with the unit circle. So I'm just going to put it back over here and use my drawing tool just to show you what I mean by knowing what the side should be. So we know that if this on the 30, 60, 90 is 1 here, we know this is double, and this is going to be the square root of 3. That's the ratio that we learned, and we can derive this, but for the purpose of this lesson launch, I'll give it to you. And if we need to spend more time, we can do that individually. So this is the ratio between a 30, 60, 90. This is a 60. This is a 30. And this is a right triangle. But on a unit circle, this is 1. So this is going to be the hypotenuse 1, and each of these hypotenuses are 1. So what do we need to do to this to get this to a 1? So to get this side to equal to 1, because it's a similar triangle, we would have to divide that by 2. So if we divide that by 2, we have to divide everything by 2, each side by 2, because of it being a similar triangle. So that's 2 divided by 2, and that equals 1. So now that relates, so we divide this by 2, so that equals 1/2, and we divide this by 2. So that's the square root of 3 equals 2. So now we can bring this back over here. And when they ask what's the x component, this length is 1/2. So if this is 1/2, then this x component is 1/2. So that coordinate point is 1/2. And this length right here is square root of 3/2. So the y component is square root of 3/2. So that's all they're asking. And it's both positive, because we know in the x, or quadrant 1, the x coordinate is positive, just as the y coordinate is positive. When we go in the second quadrant, the x coordinate is negative. So when you travel in the second quadrant, the x coordinate is negative. Then this is going to be positive still in the y coordinate. Now let's look at a 45/45. We know the ratio of this is, if this is 1, and this is 1, and this is the square root of 2. And we know this because if it's a right triangle, and this is a 45/45. These sides are equal, and this Pythagorean theorem is a sum of these two squares, so it's a square root of 2. But remember, this hypotenuse is 1, so this length here is 1. So what do we have to do to divide, or to get this similar triangle to equal 1? So it's the same thing. You divide by the square root of 2. And that equals 1. So each side we have to divide by the square root of 2. And we don't like radicals in the denominator, so we're going to multiply by 1 in the form of square root of 2/2, square root of 2, and that equals the square root of 2/2. So that also equals the square root of 2/2. So these are the two equal lengths. So if you now bring this over here, and to move these around, you have to click on this dot to be able to move it. You can't just click on anywhere on that triangle. It has to be the dot. So if we're looking at that, and we're looking at the coordinate point for this angle right here, remember in the fourth quadrant, x is still in the positive direction. And since we're going down, it's going to be negative in the y direction. So this coordinate point is going to be what we knew as this side, or this side right here, going in the x direction, is what we found to be the square root of 2/2. And since we're going down, it's negative square root of 2/2. So that's what they have you doing for this lesson, is finding the coordinate points of each of these points for all the different angles going through here, 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 here. And you know, so for if this is negative and this is positive, you should find that this is going to be both negative because you're going left and then down. So X is negative, and Y is going to be negative in the third quadrant. So that should help you get started for this lesson. If you have any questions, please send a comment and let me know. Thank you.